So there we go, parallel and perpendicular lines. So what do we know about, say, a parallel line? So let's draw an X and Y axis. Whatever lines you draw, try to make them look parallel. So what are parallel lines? If you were explaining to a kid in grade, they don't know what parallel lines are in grade 3. So say someone in grade 3 who may not know what a parallel line is, how would you explain that? What would we say? Two lines that never touch, that would be one criteria. Now, if you go on in math and you take, say, a geometry course, there is actually parallel lines that do touch in existence, but not in anything we're going to see right here. So two lines that don't touch. Yeah, two lines with the same slope. The steepness is the same even though I move the line to another spot. Okay, the steepness is still the same. That is, if we take 2 points on the line and draw the triangle between, that triangle will be the exact same triangle as this one. They have the same slope. Can you think of anything else? There is one more way to describe parallel lines. Yeah? Okay, you're getting there. So she said like train tracks. So what is it about a train track that would, a train track, yeah, and that's actually nice because a train track doesn't have to be straight the whole way. It has to turn, right? So that you're getting there. What is it about train tracks? Exactly. So parallel lines have the same distance between them, right? And yeah, if you were going to make a train track, the rungs you put on or a ladder, they have to be the same length. Or else you end up with lines that aren't parallel, right? Those ladders, those decorative ladders you put on the wall at home, like a bookshelf, they might get skinnier at the top. Those would not be parallel because the rungs are not the same size. So that's good. Yeah, equal distance apart. Okay, but for math, for now, we want to say the slopes are the same. Okay, so parallel lines have equal slopes. So what about perpendicular lines? Let's try to draw two lines that look perpendicular. Not quite. We'll do that. There we go. Okay, make yours better. Okay, does yours look more perpendicular than mine? Okay, so what do we know about the slopes of these two lines? Okay, and these ones don't look it. Let's exaggerate that. I'm going to show what you're saying. Okay, so if I have a line here, what type of slope does that have? Positive, negative, fraction, or what type? So it's not very steep, so what type would it be? Less than 1? How do we know a slope of 1? It was straight up in between, right? We said, so this would be less. So less than 1, okay? Negative? No, it's going up from left to right, so it's a positive slope and it's a fraction. Now, if I draw a perpendicular, let's try to make it look better this time. A little better. What about this one? Positive, negative, fraction. So it's a lot steeper, so the number is larger, but it's negative now. Okay, and what it actually ends up being, if we looked at perpendicular lines right through the center, here, this has a slope of 1, and this way, right through the center has a slope of -1. Do you agree with that? So they're opposite signs always, so that's one thing, okay? But they're not always the same number, like if we went through the middle. The steepness actually is opposite of each other as well, which we call reciprocals. So the perpendicular lines have negative, which doesn't mean the answer is negative, just means the opposite sign. So negative reciprocal slopes. Now, for those of you that were in French or French immersion, you might say inverse, but that's wrong. Okay, that means something else in English. So don't say they're inverses of each other. That's not the right word. Okay, so be careful of that. It's a reciprocal, and I think there is a similar word in French, reciprocal, that you can say as well, but be careful of that. Not inverse. Flipping over a number is called the reciprocal, okay, and it's actually dividing that number by 1. The other way that we can look at these is if we had two slopes and we multiply them, so put a little dot or a multiply sign, and we multiply them. Say one is A over B, and the other slope would be the negative reciprocal, B over A. You flip over the fraction, change the sign. When we multiply these, what do we get? Multiply these two fractions. Remember, when you multiply across the top. So A times B is AB with a minus, because one of them is negative. And on the bottom, B times A, which is the same as A times B because it's commutative. We can do it either way. So what? Negative 1. They cancel. So when you multiply negative reciprocal slopes, you get negative 1 always as the answer. Okay, so let's look at some examples and see what these slopes look like. So back to the same idea, find the equation of the line. Oh, sorry. Okay, so it's a little bit more complicated because I didn't actually give you the slope. So I gave you a point that we want the line to go through, and then I gave you another equation. So this equation, we could draw it if we wanted to. It has a positive slope. One of the points is 0.5. So roughly it's going to go, here's positive 5. It's less than 1, so it's going to be something like this, right? So you'd need a second point to get it exact, okay, which we did last class. How would we get a second point? Might as well do it. What points did I say were the best if you were drawing it? Both the x and the y-intercept. Now that is which intercept? The y, because it's on the y-axis, and it was given here. How do we find the x-intercept? This isn't in standard form, so it's a bit trickier than what we did last class, but this x is 0 on the y, and what's 0 on the x-axis? So if we want to find the x-intercept of this, we would let y equal 0, because we're not going up and down. We just want to go left or right. This is back to when we first solved linear equations, nothing new. We've already done this. We rearrange it. We want to solve for x. This is the one with the fraction in it, which is fine, because we'll cross-multiply when we're ready to cross-multiply, not yet. What do we have to do first? Move something to the other side. So there's only one term on each side. Doesn't matter which one. What do you want to do? Let's move the 5. Cross multiply. Minus 5 times 4 equals 3x. Divide both sides by 3. Can this simplify? No. And we don't really want to write it as a mixed number, but if you're trying to graph it, then you can do a mixed number just to see where it is on the graph. How many 3's go into 20? 6 is 18, so 6, and how many would be left? 18, 2 left to get up to 20, so 6 and 2/3. So when we draw it on the graph, this graph would be over here, and this would be the point, negative 20 over 3, or negative 6 and 2/3. Right? Okay, so there's the line that they're giving us, and they want to know the perpendicular line that passes through which point? 0, 7. Where's 0, 7? It's up here? So how are we going to get a perpendicular line? Does that look a bit perpendicular? I think so. It's negative, and this slope is the reciprocal. So that's the equation of that line that we want. So we've got a point already, and we just need to find the slope. So to do this, we didn't need to draw it, it didn't ask for that. Okay, but I want to show you what it is we're looking for. So our solution would look like this. We say, okay, the slope of this line is what? It's already in the right form to read it off. We can read off the slope is 3 over 4. So the perpendicular slope would be negative, because this one's positive, 4 over 3. This one's less than 1, that one's bigger than 1. So we've got our slope, and our point was given 0, 7. Now, if we fill this in, if we want to follow a recipe, we would always use this equation. Plug it in. What's x minus 0? Just x. Just x. And move the 7 over. Okay, that was not needed, but we just did it for demonstration purposes. Now, I just want to point out, I did this just using my recipe. I said, every time I want to find an equation, you write down this, and you need a point and a slope. What could we have done in this case only? We now have the slope we want, and the point we were given is the y-intercept. The point we were given is the y-intercept. So we could have jumped right to this form. Do you see it? There's the slope and the y-intercept. We didn't need to plug it in to figure it out. If you're given the y-intercept, you can just plug directly into this. So we'd say, okay, well, the slope we want is minus 4 over 3x plus the intercept is 7. Right? So we could just jump to that if you wanted to, or if you noticed. Some people just like to stick to the same recipe. Ask for an equation line, fill it in. It's going to work out to the same, so you don't need to do it, but I just want to show you that. Okay, so let's say another question about parallel and perpendicular could be something like this. Let's say determine whether the following systems are parallel, perpendicular, or neither. Because of course, they don't have to have the same slope or negative reciprocal slopes, they could not be. Okay, and what's a system? A system is a set of equations, we talked about that last class, more than one, and if we were solving this system, we'd be looking for the point they cross, but that's not what we're asked for. With this system, we're asked whether they're parallel or perpendicular. So how would we do that? You can't just look at it because I didn't put them in the right form to just look at it and know. So you have to rearrange them, put them in the right form so that you can look at what the slope is. So we're going to rearrange. So we want to put them in slope y-intercept form. Put into slope y-intercept form so we can compare the slopes. So if we take 2x minus 4y equals 8. Slope y-intercept form has the y on one side, everything else on the other side. So keep the y and the sign in front of it. Don't forget that. That is a minus 4y. Move the x. And that 8 is positive. What's that? Yeah, it totally would. He said, would it be better to move the 4 or the x, the 4y over so it's positive, and probably it would be, right? But the y needs to be on one side, so it doesn't really matter. How do we get rid of the minus 4? Because slope y-intercept form has a y with a coefficient of 1 only. You can't have anything else in front of the y. So how do we get rid of that? We divide it, but you have to divide. It's like you divide both sides by minus 4, and if we do that, that's this whole side by minus 4. So the way that looks is that we end up with y, because the minus 4's cancel, and this goes with each. So minus 2x over negative 4, because we have to divide both or everything by negative 4. Just like when we cross multiply, we multiply everything on the other side by that number. We have to divide everything on the other side by that number. So how would we simplify this? Minus 2 over minus 4. Careful. 1/2. 8 over 4. 2. Negative, because there's a negative. So the slope of the first line is 1/2. Now our second line, so one thing to do is to label these, like if you call this A, then we just found the slope of A. And now we're going to find the slope of B. So B yeah, and here's an example, the standard form that the x is given as a negative. So it's okay, it's just not the normal way to write it. So we want to leave the y on this side, move the x over. You don't need that plus sign. And then you divide everything by 6. So this by 6, this by 6, this by 6. So 3 over 6. 1/2. 12 over 6. 2. Are these the same line? No, this one's down 2 on the y-axis and this is up 2. But the slope here is what? 1/2. The slopes are equal. So the slopes are equal. So the lines are parallel. And any question like that, you would do the same thing. You take your system, you rearrange them, so you can read off the slopes. So how would it be perpendicular? What would we see? Negative reciprocals. And what if it was neither? then they're not the same, and they're not negative reciprocals. What I often do on a test is something like this. I'll just give them to you in the right form, but say you rearrange them. And I try to trick you. So you rearrange them and you get this. Are they parallel, perpendicular, or neither? Neither. But the number's the same and they're opposite signs, so that can be a little bit tricky to think about. So these are neither. What about y equals 3x minus 2 and y equals negative 1/3 x plus 5. So these ones would be perpendicular. The slope of the first line is 3, and the slope of the second line is minus 1/3. They're the opposite sign, and this is 3 over 1, and this is 1 over 3. So these two would be perpendicular. Okay, so we're actually done 2.1 and 2.2, but ignore the homework for those until we're done the next section. How about we say that?